Salam and welcome everyone. We're going to be solving the question on the screen that says oh, a homeowner uses 400 meter cube of natural gas a year to heat a home. Assume the natural gas is all methane and that methane is a perfect gas for the conditions of this problem, which are 1 atm and 20 degrees Celsius. What is the mass of gas used? Well, 400 meter cubed is them telling us that we're dealing with the volume, which is 4,000 meter cubed. We're told that we're dealing with methane gas, which is a natural gas, or basically which is a perfect gas because we're dealing with a perfect gas question. So therefore, we're going to be using PV equals nRT, or any equation related to PV in or any equation related to PV equals nRT in this particular question. So make sure you put this equation, the perfect gas formula or perfect gas equation, in mind. We're told what the pressure is to be 1.00 atmosphere, and we're told what the temperature is to be 20 degrees Celsius. Well, in perfect gas equation, we never use the degrees Celsius. Instead, we have to convert to Kelvin. So temperature is going to be 273.15 plus 20, which is the same thing as saying 293.15 Kelvin. So we've gotten the temperature in kelvins, which is what we want. Now, we're told that what is the mass of gas used? Well, we don't know what the mass is because that's what we're trying to solve for. Now, looking at the equation PV equals nRT. We have to observe that we've been given the pressure, which is 1 atm. We've been given the volume, which is 4,000 meter cube. We've been given the temperature, which is 293.15 Kelvin. And we know what the gas constant is because the gas constant is a constant. So the only thing we actually do not have in this question is the number of moles. But since we're supposed to find the mass, and we don't have the number of moles, but we have the perfect gas formula, we have to first of all find the number of moles based on the parameters we have, and then use that number of moles to find the mass. So we have to now look at all our questions to make sure that all our units are proper. We have the temperature proper, the ATM proper, but we don't have the what they call it. We don't have the volume in the proper units because we would want to be able to solve this in dm cubed or in liters. Note that dm cube and liters are basically the same exact thing, right? So we know that we're dealing with 1 meter cubed. So I'm trying to compare 1 meter cubed to 1 decimeter cube. So 1 meter, we first have to remember that 1 meter equals what? 1 meter equals 10 decimeter, right? Hence, when we now decide to cube the 1 meter and cube the 10 decimeter, we realize that 1 meter cubed is the same thing as 10 decimeter times 10 decimeter times 10 decimeter. So inherently, 1 meter cubed is the same thing as saying 1,000 decimeter cubed. So that is how you basically do that. So now we're told that we have 4,000 meter cubed. So we're supposed to convert 4,000 meter cubed to whatever it is in decimeter. So we have 4,000 meter cubed equals what? Since we're trying to find what it is in decimeter, we're using the proportionality formula to be able to like work with this. So what that means is to tell you that we're just going to cross multiply because we've already determined that we know that 1 meter cube is always going to equal 1,000 decimeter cubed. So that therefore 4,000 meter cubed equals what? So that's going to be the unknown x, the volume that we're trying to find in decimeter cube for 4,000 meter cube equals 1,000 times 4,000. And remember, we're dealing with meter, we're dealing in trying to solve in decimeter cube. So the meter cube here, the meter cube here will cancel out. And we have to retain the decimeter cube since that's what we're solving for. So what we end up with is 4 million decimeter cubed, which we can simply call 4 times 10 raised to the power 6 decimeter cubed, or 4 times 10 raised to the power 6 liters. One of the two is all right. Does that make any sense? Yep. So that is how you do it. So PV equals nRT. So now we have the volume to be, 4 times 10 raised to the power 6, 4 times 10 raised to the power 6 liters. So yeah, or DMQ, whatever you want to call it. So we have the P, we have the V, we have the R, we have the T. So N equals PV over RT, so which is pressure 1 atm times 4 times 10 raised to the power 6 liters divided by the gas constant, which is 0.08206. It's important for you to memorize the two gas constant that we have whenever you're dealing with perfect gas law. You have the first one, which is one I just had, 0.08206. So this is just a side note, liters ATM divided by mole Kelvin. And then you've got the second one, which is 8.3145 joule divided by mole Kelvin, or 8.3145 kilopascal liters divided by mole Kelvin. So make sure you memorize both, because there are going to be questions where it is better for you to use the one on the right, and there are going to be questions like in this case where it's better for you to use the one on the left. So that is it. So let's continue our work. So we have this times the temperature, which is 293.15 Kelvin. So we're going to cancel out the Kelvins here. We're going to cancel out the atmosphere. We're going to cancel out the liters, leaving us to have just the mole, which is what we need, which is what we're solving for. So the number of moles is going to now equal 1 times 4 times 10 raised to the power 6 divided by 0.08206 times 293.15. I'm rewriting this for all the students who may not be able to see clearly. So you input all this information in your calculator to get 66 comma 279.5 mole. And I'm sure this is scary to you because you're used to seeing the mole being a small number. But let's not forget that they talked about the natural gas that is used to heat a home for a whole year. So this is the number of moles for the whole year. So I just wanted to make sure that that is remembered, so that you're not scared thinking, why is the mole so large? It's not a small vessel or small container. You're literally dealing with an entire house being heated for a whole year. So yeah. So now we have the number of moles. From the number of moles, we're supposed to find the mass. So to do that, we have to remember the very common formula in chemistry, which is number of moles equals mass over molar mass. And in this case, we have the number of moles, which we have 166, 279.15. Since we know the identity of the gas, since we know the identity of the gas to be CH4, we can easily find the molar mass of CH4 by calculating it. We've got carbon, we've got hydrogen, we've got four hydrogens. So we have the atomic mass of carbon plus the atomic mass of 4 times that of hydrogen. So 4H, you can do that on the side notes. I'm not going to do that for you guys because it's just simple chemistry. Just solve for the molar mass. You're going to find the molar mass to be 16.04 gram per mole. That's what you solve. Remembering that carbon is 12 and hydrogen is 1. And since you're 4 hydrogens, that's 1 times 4, which is 4. So 12 plus 1 is basically 16. And the zero point zero 0.04 comes from the fact that hydrogen is actually 1.01 gram per mole when you're solving for the atomic mass. So I don't need to like write all of that down. I can just say it. So to find the mass, we would just cross multiply and have the molar mass times the number of moles, and then we're going to get what the mass is. So the molar mass and number of moles is going to be us multiplying 16.04 gram per mole, okay, times the number of moles 166, 279.5 mole. We're going to cancel out the mole, and we're going to end up with 16.04 times 166,279.5, which is 2,667,122.4 grams, which when we do it and we basically approximate, we're going to end up using 3 sig figs. We're going to end up with 2.67 times 10 raised to the power of 6 grams. So the answer to this question is simply the mass is 2.67 times 10 raised to the power of 6 grams That is the mass of gas used in the entire year to heat up the home. I wish you guys all the very best. If you have any question, please put it in the comment section. If you want me to be your personal tutor, make sure you email me at shuhabitutoring@gmail.com. I am a tutor for students all over the world. So if you need help in various STEM classes, whether you're in high school, middle school, and college, I am your go-to tutor. Make sure you put in the comment section what else you want to see next. I wish you guys all the very best. Assalamu alaikum wa rahmatullahi wa barakatuh.